What's up, everybody? This is Ryan here, and you're watching episode 46 of my live stream Q&A. So, I don't really plan to do a huge long lesson, but we'll see. I might end up rambling for a little while. Today's main topic is I can't talk. Today's main topic is a discussion of software architecture. You guys are gonna have to bear with me here. All right. So before we get to that, just a couple of notes. So number one, Monday streaming schedule. So today is Monday and not Sunday, and the reason for that is because for the past, I would say, with like one or two exceptions, no, three exceptions total where I just didn't stream. I've been doing the Sunday live stream, generally speaking, off of, I would say, 90 minutes to 4 hours of sleep each time. And the main reason for that is just because of the nature of my current day job. I work quite late on Saturday nights. Well into Sunday morning. Like, to give you an idea, I wasn't out of work until 3:30 a.m. on Sunday. So the thing about that is that in order for me to do a half decent live stream, I need to get up, I would say, at least 2 hours before my scheduled time to start streaming. And most of that 2 hours is really just me doing a whole bunch of different sort of things I do in my morning routine to wake my brain up and do a little bit of preparation. And so just the result of that is I was sometimes doing, like I say, I remember one Sunday I did the live stream off of 90 minutes of sleep. And that's just not very healthy. Like, on one level, you want to be able to sort of, sorry, let me ramble for a bit here. On one level, you want to be able to, at least for me, one of my main goals was getting to the point where I can still get my work done even when I'm quite tired, but I don't ever want to do that deliberately or do it for the sake of doing it. So in any case, since I generally get Sunday, Monday off, finally on, I think, Saturday, I realized, why don't I just stream on Monday instead? So sure enough, I actually got a decent night's sleep last night, even though I'm sure I don't look like I did, but I can tell you I'm a lot better off today than I was yesterday. So anyways, for the foreseeable future, no, not the foreseeable future, but for the next couple of months, most likely, I will be just doing this live stream on Mondays instead of Sundays. I realize that might displace a few people, but at the end of the day, I was basically sleep deprived for pretty much the entire week last week, and when you start having like successive days of just not getting quite enough sleep, even if you're exercising, eating well, and doing all that stuff, I was finding myself kind of getting stressed out and pissed off over small things. And when you find yourself getting stressed out and pissed off over small things, well, assuming that's not something you typically do, then that's kind of a signal to, take care of yourself a little better. So anyways, that's my explanation of why I am streaming on Mondays now, and hopefully that still works okay with the majority of my viewers, but we'll just have to see. So that's pretty much, I think that's the only announcement. Just for people's general information, why I haven't uploaded any more videos or been really active on the Slack channel or anything like that. I am still just knee deep in building what I will call the first major commercial project that I've ever worked on with a team of developers, and these developers also happen to be part of the WiseAss community, so I'm very, very happy to be receiving their help with it. So anyways, like I said, I'm still knee deep in that project, and part of, I can't talk about details yet, but I wanted to talk about a general topic today before we get to the Q&A, which has been a huge headache for me in this project. Again, I think what I'll try to do is at some point once the project is released, I'll try and describe some of the difficulties I had in building some of it. But to give you an idea, I'm at the tail end of one of the most frustrating and difficult programming problems I've ever had to solve. I've basically spent roughly, well, 2 problems total that are similar, but I've spent roughly 11 days, I would say averaging 4 hours a day working on this one problem, and it's just been a major headache. And why has it been a headache? Jargon and just poor documentation primarily. Just people not really taking the time to explain what their APIs do. So I can't complain too much because it's, I won't tell you what API it is, but it is an open source API. But yeah, just suffice it to say that's been, to give you an idea, all I do with my spare time right now is I work on this project in the spare time I have outside of my day job, and then I go to my day job and I do that until late into the night, and then I get up and then I code, and then I go to work and then I get up and I code, and that's basically been my life for the past 11 days. So I'm not complaining, I choose to do that, but I tell you, it gets monotonous. Anyways, let me stop rambling and let's get to today's primary topic. But first, let's just say hi. Who do we got in the stream? All right, we got Linksy, Rahul, Josh, Rafe Backup. That's an interesting name. Nalan, and yeah, welcome everyone. So I see we have a couple people asking about architecture, software architecture, and this is something I get asked about all the time. Ryan, could you explain Model View Presenter? Ryan, could you explain Model View Viewmodel? Ryan, what is Model View Control? I can't talk. What is Model View Controller? I have one question. What is Model View Intent? Unfortunately, I haven't actually looked into Model View Intent, so I couldn't give you a good explanation of that. But what I'm going to do instead, and this is my lesson for today, is I'm going to talk about the 3 primary foundational building blocks of probably every architecture you will ever use, regardless of what it's called, and how to actually understand why we can call it different things. We can call these things model, we can call these things view model, we can call these things presenter, controller, all the different jargon terms that people like to use. But what are the actual pieces that are necessary to build a software architecture? Just a general purpose application, something that you can use in almost any kind of project. There are special cases where you'll need a different architecture, or if you're working with a very small application, you might not need all of these things. But what I wanted to help everyone with, especially the beginners, is to try and provide an understanding of like what are the actual pieces. Like to give just a quick analogy here, so let me just start this off by saying, so today's lesson, I'm making this up off the top of my head, so we'll see how this goes. The fundamentals of any whatever, I'll probably get in crap for saying that, but the fundamentals of any decent software architecture. Now, before I get into discussing the architecture specifically to do with software, I want to start everyone off with like a little analogy that I like to use. So this is an important point. So since I'm a very visual thinker, one of the biggest difficulties I had initially with learning software architecture is I didn't really have like a visual metaphor to picture it in my head. So what ended up happening is I would read an explanation of Model View Presenter and I would be able to maybe recall, okay, the model does this, the view does this, and the presenter does this. And I would have to like remember it in just kind of a word, a definition by definition thing. A very, oops, there's a Slack message. A very lifeless and rote way of thinking about these things. And after a while, I started to understand, why do we actually call this stuff software architecture? So what I'm going to show you first is I'm just going to try and get, especially the beginners, provide a little way of thinking about this, a visual metaphor. So software architecture happens to be highly analogous, I'll say similar for, I know some people are ESL here, happens to be highly analogous to building architecture. So how is that the case? Well, let me just give you the basic metaphor that I always use. So when you're designing an apartment, because that's things that we do all the time. We're always designing apartments. When you're designing an apartment, if you want to be a kind of super hyper critical about this, you can probably poke a few holes in this analogy. Really what I'm just trying to give you is a way of thinking about it, and I'm not trying to say that software architecture is exactly the same as building architecture, but just try and just run with the example with me. So when you're designing an apartment, any basic apartment, or for my friends from the UK and so forth, a flat they call it. When you're designing an apartment, any basic apartment requires these three things. Now, again, like I say, this metaphor can break down because I know there might even be people listening who don't have access to all these three basic requirements, but just stick with me. So number one, you need just to generalize it a bit, sleeping area. We'll call that bedroom. You need a food production / storage area, so kitchen. And you need let's say a waste management / sanitation area, bathroom. And those are like the three main things that almost every building or apartment will require in order for it to be to function as a decent living area, let's say. So I want you to kind of bear this idea in mind and almost try to begin to think of your architecture as being like, okay, I need these specific rooms, and the reason why I need these specific rooms is because this is what is required of any basic application or any basic living space. So with that explanation, I'll jump into my diagram here on the actual software architecture. And now this is what I'm about to show you. This is heavily influenced by Martin Fowler and Robert C. Martin, but this is actually an original way of explaining this. This is the way I have moved towards explaining software architecture. Let me see if I can find the friggin' file now. There we go. And the reason why I started to move towards thinking about this in this manner is because I am just so, I almost swore, so bloody fed up with jargon and people using stupid, overly technical names for everything in this industry. And the funny thing about it is, going into learning computer science as a self-taught person, basically, I have one introductory Java course, and that is the extent of my formal education. Well, I did take like a course or two in high school, but I did horrible in them in programming. But as far as post-secondary, I have one Java class, introductory, and that's all I've ever learned from post-secondary. And one of the things I thought early on is I thought, okay, the reason why all of these things have these insanely complicated and overly technical names and explanations is because they are just very technical and difficult subjects. Now, with little exception, there are a few topics which are quite complicated, but the vast majority of them, they're not actually that difficult. They're not that technical, and if people would just give things good names, then it would save people like me potentially years and months of research time. So what I'm about to do for you is I'm about to show you a diagram I made in 20 minutes this morning, which will hopefully explain the fundamental things you need for most architectures you will build. So let's have a look at our diagram. I'm probably just going to hide my face for a minute here. Oops, there we go. Okay, and here we go again, struggling with the Windows photo viewer, but I will do my best. The good old Windows 10. Okay, so when we're speaking of software architectures and basically any application you will build, there are three kinds of things you will almost always require. Number one, let's hop back into Notepad for a minute. So, we're going to go back to these three main things, except in software architecture. So number one, you need a UI renderer / binder. So this is a fancy way of saying something that handles UI. So that's number one. You'll need something to handle the user interface, because if we don't have a user interface, we don't have an application. So if I hop back into my diagram here, this is one of the few things in software architecture which is pretty constant. We generally like to call this thing a view. Its job is to build the user interface, bind to it, render it. It's user interface stuff. So that's kind of the first piece. Now, the second piece is we require decision makers. Usually two. We usually need two decision makers. I'll explain why in a moment. What's a decision maker? It is an object which is primarily concerned about taking inputs from other objects, messing with them, changing them if necessary, and then giving them back to whatever object is whatever is required. If we want to think of this in a more functional way, we could say that this decision maker is responsible for event handling. The view has a button click. The view then says, hey, but this button was clicked. And then the decision maker takes that input and decides what to do about it. Hopefully that's fairly simple. Next, we have data management. I think that one's pretty self-explanatory. The only thing I'll say about it is whether it's on the device, or it's on a cloud server, or it's some bit of data that is taken from a phone's system service, so like a location sensor. It's just data. We're talking data storage and data sources. We need stuff to do with data. So these are the three fundamental kinds of things we need in almost any architecture, and this is something which I've found to remain quite constant. So this is like the general thing. Now what is if we were to try and build something like this for a general purpose Android architecture, what would it look like? this diagram right here. So in a sense, I want you to think of this again as like a 3 layers in a sense, although we have a front end and a back end. And how this kind of works is we have, of course, the view here. We have decision makers. And I want you to take note, we have both a front end decision maker and a back end decision maker. For the front end, we also have a front end data store. And that's going to hold temporary data. So for example, let's say the user rotates their phone. You should not have to query a cloud data service just to reload the data when the user rotates their phone. That should be stored temporarily in some kind of front-end data store is what I call it. You don't always need this, but generally you will. If you need data that persists across orientation changes and just user session data, you will need, now you can kind of put this in the back end too. On Android, I'm suggesting you have like a Viewmodel to do that or something. Again, I don't want to get into the jargon because then it's going to start confusing people. But for those people asking about specific architectures, just a minor note, the presenter and the controller, and in some cases the Viewmodel, it's a decision maker. It's not responsible for storing data. It's not responsible for drawing the UI. It coordinates these things. I actually like to call this thing down here, the front-end data store, as a view model, because to me, it's a model of the view. The front-end data, temporary data, is a model of what we render in the view, unequivocally. I don't like that some people make it into a decision maker, but I accept that, you know, people have differing opinions there. That's okay. So yeah, so that's the front end in a nutshell. And then we have the back end. Now, all we're really saying here is we have this decision maker class. Now, these things are typical. Oh, someone is phoning me. Whatever. We typically have a data source. Sorry, that distracted the hell out of me. We typically have use cases or a repository or an interactor. So what does that thing do? What does the back-end decision maker do? It's basically going to coordinate, as Robert C. Martin likes to say, it's going to coordinate the dance of the back end. Now, this thing doesn't always need to make decisions. If your app is very simple, it generally is just used as a way to abstract away to hide what happens in the back end from the front end. So instead of having our decision maker out here talking to data source A and talking to data source B, we hide it. We hide these things behind a decision maker or even just an abstractor at the most basic level. You can also have this thing make decisions. So we can have this back-end decision maker do the work of taking in input from a cloud service and the device and deciding which to give the front end first. It does those kinds of things. And then we have, of course, data sources. So one of the most powerful ideas I ever learned from Robert Martin is this very simple idea that whether we are talking about data that comes from a cloud service or the device or the phone, which I threw across the room because it was ringing, so I don't have it anymore. Regardless of what you do, these are all just I/O devices. In, out, data in, out. It's just data sources. We don't need to, handle them extraordinarily differently. We can all just treat them as some container for data, and that's basically that. So, what I've tried to explain here is that this is typically what you will require with some nuances. Obviously, this will change kind of, so you won't always have two data sources. Sometimes this decision maker over here will actually not really make decisions. It'll just give you, it'll just abstract out what happens in the back end. But you don't want your front end decision maker speaking directly to your room database, for example. You don't want your decision maker speaking directly to Firebase, in my opinion. You want it speaking to some kind of abstractor or etc. If that word abstractor or abstraction is unclear, please let me know and I'll explain that, because that's a very important concept. So I've showed you two levels of this metaphor. So I've showed you one that has to do with building architecture. I just showed you an explanation of the fundamentals of a software architecture in terms of boxes and sticks with some words. Now what I'm going to do is take you through the actual code, and I will show you that it almost directly reflects what I just showed you here. So I'm going to open up Kotlin MVB calculator, and the link in the link to the repository should just be in the description. And I'm going to open up the different parts of this architecture, and we're going to talk about them. Holy crap. Okay. So, and I'm going to make my face reappear here. There we go. Okay, so let's pull this up one. So let's go through the front end first. So let's start with user interface. In this case, this is a model view presenter architecture, which uses a view model as a front end data store. So we'll first go quickly over the front end. So for the front end, we have the presenter, we have the view model, and we have the view. And what do they look like? So my view is a fragment in this case. I had a question from someone about whether fragments are good to use as a view. I would say that fragments are like pretty much exactly designed to be used like views, just in case that person is listening. So what does the view do? It binds on-click listeners, and it binds data. It takes data which is given to it from the presenter, and it binds it to the user interface. So we do have the most minimal amount of logic in here, like we select for view IDs which are clicked, but for the most part the view is very dumb. It does what it's told, and it takes inputs and just hands it to the presenter. It doesn't make a big deal out of it. Let's go to the presenter. So the presenter references, has a line drawn to the view and the front-end data store, which in my case, I make that a view model because it works quite well. So as you can see here, that line represents this view here, and the other line represents this view model. So the presenter directly talks to these two things and will feed them information, data, listen to them for events. So like I say, if the user long clicks the delete button, we set this front-end data store, this one here, we just say, okay, just clear it out. In this particular application, it's a calculator, so there's no back-end data storage, but there is a back-end, which we'll talk about in a minute. Like I say, these things will change a little depending on the nature of the application you're building, but this is a general way to lay it out. Okay, cool. So we've got, oh man, how long have I been rambling? Like a half hour? Yep. I said I wasn't going to talk for long, but I'll stick around for some Q&A for sure. So yeah, this thing basically just manages what I just explained here. Now it uses the RxJava magic and all that stuff, but we don't really need to talk about that today. And that's basically the gist of the presenter. This calculator view model I've been talking about, the front-end data source, it basically contains a representation of the data that we need to represent in the user interface. Now, through the suggestion of my friend Darrell Bitsy, who's an amazing developer, he suggested that I use a, where did it go? Behavior subject, and use the behavior subject to basically automatically update the presenter every time the state of this view model's data gets changed. Anyways, I'm probably losing people. We're getting a little technical there, so I'll move on. Sorry, I can't help but ramble about that stuff. Okay, so I've just demonstrated to you the front-end general architecture, and you can call it different things. You can have a view model as the decision maker if you really want to, whatever. Let's move on to the back end. So for the back end, we have two data sources, or n number of data sources, but most importantly, we have this decision maker, which sometimes can be a use case if you like that. It can be an interactor if you're Uncle Bob. It can be a repository, as my fellow developers that I talk with have taken to calling it. And ultimately, whatever name you call it, it's a back-end decision maker / abstraction tool. So let's see here. So that's going to be, in this application, the domain. So in this case, what do we have here? This one's a little different because it implements a couple of different ideas, but this is basically, this evaluate expression class here is the backend decision maker. Now it talks to a repository. I don't want to confuse anyone, but just don't overthink this part here. As long as we're not talking directly to the data sources through the presenter, we have this thing in between which talks to the two services. Now in this application, it just so happens that I do have two data services. Or data sources. So one of them is a calculator and one of them is a validator. And really all that happens is when the user hits the equals button, the whatever is written in the display, the calculator's display, gets sent to the back end, and it first goes to the validator to make sure it's a valid expression, and then if it passes that check, then it goes to the calculator to find the answer. And that little bit of logic, oops, wrong application, there we go. And where did it go? There we go. And that magic happens in this use case type thing here. And all it does is it gets the string expression, like I say, whatever is in the display. It asks the validator to do its work, which actually happens synchronously because the validator is not a long-running operation class. So I'm not going to make everything into a data stream if I don't need to. And then it sends the expression to the calculator. And then I won't get into this stuff here just because I'll confuse the hell out of people. But that's basically it. And then these are like the calculator implementation and the validator implementation. These are like the low-level services or data sources or whatever you want to call them that actually work with the data at a low level. And those are the things I don't want the presenter or the controller or the view model talking to directly. So at the very least, talk to them through an interface. At the very least, use an interface. So I think we're going to shut up now because I've been talking for about 30 minutes. And that discussion was meant to be a general purpose overview of software architecture. And hopefully I've dispelled a few wrong assumptions you might have had, or maybe gave you a few good, maybe gave you a good way of thinking about this that isn't just like, this thing does this, this thing does this, this thing does this, but more like this is the foundation of a software application. So that was my off the top of my head rant about software architecture. If you enjoyed my ranting, you'll probably want to read my article on this stuff. I wrote a long article on my blog, which is called WTF Does Model View Presenter Actually Mean? Now, this article focuses on Model Presenter, which is my favorite general purpose architecture. At the very least, it's the least ambiguous of the other ones. Model View Viewmodel is highly ambiguous, and that's my biggest complaint against it. But if you'd like some more information on this, you can check out my blog, link in the description box down below. And this is an article where I go into fine detail about three-layer architectures, and you'll see a lot of the same themes that I discussed today. So with that, I'm going to run a quick commercial break. If you enjoyed that, please do me a favor and hit the like button down below. Consider subscribing, and I'm going to drink some coffee. Oh, wow. See, that's what happens. One of my biggest secrets that oh, that was a good voice crack. One of my biggest secrets that people don't realize is that I'm like super ADD, and I would say I think about things very deeply. And so sometimes that's actually like my biggest weakness, but it just so happens that when I'm talking about software architecture, at the very least, I bounce around so many different topics and cover so much ground that when I attempt to explain something, which I think will only take me like 5 or 10 minutes, boom, 35 minutes go by, and yeah, I think I've chosen a decent career for myself in rambling about this stuff. Because I actually just enjoy talking about software architecture. Nerd! What a nerd! Okay, here we go. So, what do we got? So a couple different questions. Can I talk about Mdi architecture? I don't actually understand Mdi architecture enough to talk about it, just because I've never really learned about it. I do know that it was created by Hannes Dochman? Or am I mixing that up with someone else? I have to Google that now. Did he do MVI? Yes. Yeah, I tell you, that's a German name if I've ever heard it. So it's something I've been very curious about, but my current architecture works fine for what I do. I do want to learn it, but I just can't really explain it to you, so I'm not even going to try. But what I would say is, again, like whatever architecture you're using, to a degree, it's always going to be a division of user interface, decision makers, data stuff. And so they don't tend to really deviate a whole lot from that. They just lay things out differently. Really, like the primary difference between most architectures, honestly, is the way these lines are drawn. That's honestly, like, in a nutshell, what differentiates most architectures. It's almost not even like what these things do, it's just the way that they relate to each other. Because like I say, it's always, you need a user interface, you need decision making, you need logic, and you need data storage. Anyways, let me get back to questions here. Do I have any tips for becoming good at model view presenter pattern? I can riff on this for a little bit. Okay, so I'm just going to call you WB. WB asks, do you have any tips for becoming good at model view presenter pattern? And WB mentioned that he or she watched, statistically speaking, probably he, but watched my videos on model view presenter, and it's still something that's kind of difficult. So what I would suggest to you, WB, and maybe you've done some of these things, but my biggest suggestion when I get questions like this, do you have any tips for becoming good at X? This is what my general tip for almost learning anything in software architecture. Follow what I call a project-based learning approach. So, if you've read some articles, you've watched the videos, and you've done that and you still don't really feel like the concepts are very clear in your head, you need to write code. You need to understand these things in code. Because one of the things that, again, I talked about certain things about me that are at different times a superpower and at different times a major issue, is that a lot of this stuff that I'm teaching people, I don't really understand it through the jargon-based descriptions of it. I understand it because I've built a lot of architectures. I've written a lot of code. So I actually understand what model view presenter means in the code, and I've made so many mistakes along the way trying to build it better and better and better and better over and over again over the span of years that I've gotten to this point where I can kind of generalize things. So my biggest suggestion is follow a project-based learning approach. So build an app which applies model view presenter architecture. So that's the main thing. Have some good quality open source repository to base the project on. So this is what I always did. I always had good code, good working code to base my code off of. And that's the best way to learn. It's like having someone, it's the difference between having someone explain how to build a house and having someone show you, demonstrate to you live how to build a house. So my suggestion, so let's say, so here's some learning resources for MVP. For my stuff, check out, you might be a Java developer, so this one might not help so much, but Kotlin MVP, Calculator. We have Android REST tutorial, POS trainer, and my stuff, so my GitHub account is bracket cove. Link should be in the description box there. And I link to most of these in the description box. So for my stuff, you can look at these. These are Java projects if you're curious. My favorite external resource is, these are linked, but in the GitHub Google samples, check out Android Architecture Blueprints is one, and then Android Architecture Components Samples. Both of these are basically giant repositories made by really good developers demonstrating a whole bunch of different approaches, architectures, and APIs. So this is where you need to go from here, Mr. WB or Mrs. WB. This is really what you need to do. My suggestion is if you're like hitting your head against the wall with videos and articles, stop, just cut that stuff out, start writing code. Make a project, probably I would suggest a calculator. If you want to go a little higher, do a note-taking app. That's another good way to learn the basics of an architecture. Do that and you will be on your way to mastering Model View Presenter. Or at least understanding it better. What else have we got? What is Jetpack? I don't actually know. I'm assuming it's some kind of developer tool service thing, but there's like 500 of them, and I haven't worked with that one specifically. How can I use a Recyclerview, one Recyclerview adapter in 2 fragments? So, I've never done that before. Could you, if I recall correctly, this is Mr. Singh asking this question, but correct me if I'm wrong. Can I ask why you want to do that? Because you're asking to do something which is going to be difficult. Because the problem is, to give you a vague idea, the problem is if I've never actually built it myself, it's hard for me to guess off the top of my head, because there could be really big, when you want to do something like that, it could be quite difficult. Maybe what I would suggest is you're going to need like some kind of decision maker which supervises both fragments, and then maybe you have like an adapter out here, but that might not actually work well at all. So what I would ask is, why do you want to do that? What is your, what are you trying to do? Because there might actually be a different way to do it, which doesn't require these kind of, the problem is when the more things you have to manage in one activity or feature of your application, the more you need that logic to like share data and remember state between these different things. And it's not that you can't do that, it's just if you can avoid it, I would suggest avoiding it. But maybe you've got a specific sort of idea you had in mind. All right. I can, so WBS, if I can upload a picture of the diagram later, I certainly can do that. If I forget to, feel free to message me on Facebook or whatever and just remind me, because I might forget, but I'm happy to do that. All right. Pratik asks a pretty complicated question about bridging RxJava backend with live data for the front end using live data reactive streams. So unfortunately, Pratik, I've worked with live data in isolation, and I've worked with RxJava in isolation, and I'm moving towards using live data for the front end. But I haven't actually worked with live data extensively. So the question was, one of the issues with live data is that it doesn't handle errors. Here might be a useful suggestion. This one might help you. I'm going to give like a general answer just because I don't have code to show you, but this answer might end up helping you. Okay, let me just get some, let's get some room. There we go. So Pratik Pratik asks, I'm trying to bridge retrofit/RxJava, the backend, with live data in the front end using live data reactive streams. So like I say, I haven't actually worked with this, so my answer will be limited. Live data doesn't handle errors, so I absorb them with on error resume next. Is there a better way? My suggestion is I like to pass around what I will call data models, which are capable of representing both successful operations and unsuccessful operations within one object. So, for example, if I hop into Kotlin MVP calculator, that's not Kotlin MVP calculator. There we go. As you see, I have this object called an expression, which represents like a mathematical expression. And this is like my mid-level data model. I'll typically have data models for the low-level services, for the kind of domain area. We're getting into more complicated stuff for the beginners, so apologies to beginners, but for like the middle of the application. And then for the front end, I'll have like I'll have sort of the view model thing. But this expression object is capable of representing, it's capable of returning a successful calculation, and it can also return essentially an error, although it's the same object. And I use this little kind of static factory for it. So what might work for you, Pratik, is have an object, pass an object through live data, one type of object which is capable of representing different kinds of states. So that way you almost can represent everything in one data model. And then once it makes its way to the front end, you can just have your front end decision maker check whether it was a successful, or it's loading, or it's a failure through an error. And you can probably handle it that way. So hopefully that kind of helps you out. As far as like how to do this programmatically with this thing, I haven't done that yet, so I can't help you there. Okay, I'm just going to run another quick commercial break and drink some coffee. Excuse me. Okay. So, I'm only going to do a few more questions because we are getting to the hour mark almost. So I've got a question from Rahul, which is, will I be making a video demonstrating the use of different product flavors and build variants? I don't, so right now I'm not really making any videos other than the live stream, just because I'm literally busy building a complicated commercial app here, but the answer is kind of no. I'm just trying to think, is there any resource I can point you to? Rahul, what I would suggest, do check out these repositories here, and you should see some good code examples for how to have different product flavors. Typically speaking, to get started, all I would suggest you do is have a mock build variant / product flavor. I'll just say build variant, a mock build variant, and a production prod build variant. Use the mock for JSON tests, or not JSON, sorry, JUnit tests. use the production for the actual thing you will release to Google Play eventually, or, you know, get started using that. And it is a little annoying. There's a couple steps involved in adding a product flavor, which are a little annoying. Like, for example, in this code here might not actually work because I haven't updated this project in like a year. But the basic gist of it is you'll add these. This process might have changed. In newer APIs, you need to specify something here. Maybe it's the dimension. I don't know. It's been a while since I looked at the explanation of it, but you'll need some code in your build Gradle. You'll need to do that, and then you'll need to once you have that code ready. Can I drag this over? What are we doing here? Move to left. So once you've added your stuff to build Gradle, whatever product flavors you want. So in this case, I just have mock for tests and prod for the actual production. Go to your project explorer. Make sure it's on like project files or project, because it will actually hide things from you if you're in a different view. And what you can do is in the source, I know this is hard to see for people, but in the source folder for the module you're working in, you can right click on it, go to new folder, and I believe Java folder. And then if you've configured your Gradle stuff and you've done a Gradle sync, you should see your different build variants and so forth show up in these target source sets. Select whichever one you want, and then you can create like a source folder. I'm not sure. I'm not actually going to create this because I don't want to fuck my code up. Pardon my language, but and that's basically how you set it up. Once you've done that, you can now, in the build variants tab down here, again, I know that's hard to see, you can switch the build variant to whatever you want. So when you're executing unit tests, switch to mock debug. When you're just testing the app, the production app, just go to prod debug, you know, however you configure it. And so in a nutshell, that's like my 2-minute guide on setting up product flavors, and hopefully that helps you. I don't plan to make a long video because it's actually, it's not very complicated. It's just explained very poorly as usual. It sounds complicated because they've got product flavors, build variants, product dimensions, just there's all these different things, and they don't really explain to you what they're for, but you'll only need them in specific use cases. So maybe you have like a build variant, maybe you have a build variant which has ads in it, maybe you have a build variant which doesn't have ads in it. So you're going to want to separate it based on that stuff, but the most basic useful way to do it is have a product flavor for tests, have a product flavor for production, and that's a good way to get started. At least that's how I got started with it. Okay. Okay. Let's see. I can't give you a long answer here. This is I'm not the best with pronunciation of names here, but I believe your name is pronounced maybe Naleen or Nalin. I'm going to assume Naleen. Naleen asks basically when to use model view Viewmodel. So there's really not an easy, there's no easy answer. Um, what I will say, so the benefit of Model View Viewmodel, the primary benefit is that you can have a many to one ratio of views to view models. And the reason this is because view models may never directly depend on any view. They may only expose data to whichever views happen to be listening. So let me pull up another quick diagram which will kind of help explain this. If I can find it. Here we go. Okay, so this is like a general description of Model View Viewmodel. So the most important thing you need to understand about the actual difference between, say, Model View Viewmodel and Model View Presenter is that in Model View Presenter, for example, this arrow just points directly to the fragment. And what does that arrow actually mean? Each of these arrows represent a dependency. A dependency is what an object may talk to. So in a Model View Presenter, the presenter directly holds reference or has an arrow pointing directly to the view, which is in this case a fragment. In Model View Viewmodel architecture, we may not see any view model. Let's just pretend this says view model. We may not see any view model talk directly to a view. That is not Model View Viewmodel architecture if it does. How does it actually give data to the view then? When you're using Model View Viewmodel architecture, you need some tool, which could be live data, it could be RxJava, it could be data binding. You need some way to expose data to a view, and the view, see this little observer thing? The view observes the data from the view model. So the view model doesn't give the fragment the data. The view observes the data. That's literally the difference between Model View Viewmodel. Every Model View Viewmodel architecture I've seen and every Model View Presenter architecture I've seen, this is literally the difference between it. Is that the view listens to the view model. The view may talk to the view model. The view model may not talk to the view directly. It may only expose data. So your question is when to use Model View Viewmodel? When it benefits you to have a setup where you can share this view model with multiple different views. So what I would say to you in general is what benefit you might get from doing that, you might also get issues. Same thing with Model View Presenter. In a nutshell, there is no easy answer here. All you can do is use what you think is the best architecture to solve the problem at hand. How do you figure out what that is? Work with all of them. You're going to need to work with them. You're going to need to build a model view Viewmodel app and a model view presenter app in order to actually understand when this one is a better one to use in this particular application, or when this one is a better one to use in this particular application. Or you can do what I do, which is I take bits and pieces of many architecture, well, not many, a few architectures, and I'll use them together in what I think is the best sort of setup. So what I'm really saying here is, Nalin, is that there's no easy answer, and you're only going to find this answer if you understand all of them. So yeah, that's basically my answer there. It looks like one of a regular contributor, one of the regular contributors to the Why Is That Slack channel, Al, had the same idea for solving the live data issue as me, so I'm very happy to hear that because I know Al is a great developer as well. But yeah, that's a very powerful concept, having one object passed around the architecture that is capable of representing different states. So error state, loading state, success state. And then you've basically covered most of your bases. And so Pratik asks a follow-up question, which Al also answered the same way I would answer, which is so basically, Pratik, what you need to do is this is the reason. So what you just kind of mentioned here is that the reason why we want this repository, this decision maker, is so that we don't have any retrofit or volley or Firebase or Room or Realm or whatever specific implementation you're using. None of that should be known about in the front end. You should have an object in the middle here which gets passed that doesn't have any reference to whatever specific APIs you're using in the backend. You can use RxJava or live data as like a communication tool, but other than that, I never want to see a presenter knowing what kind of database you're using. Just in general, your presenter does not need to know if you're using Realm or Room. It shouldn't know, I would even go so far. Why? Because if it knows the specific thing that you're using, let's say your requirements change and your boss says, okay, I want you to switch from Realm to Room. Now that if your presenter knows what specific API you're using, you now have to change your presenter. You need to go back and fix code which should not have to change. Instead, if you've applied separation of concerns and you've sort of abstracted away all your backend stuff through both a repository or use case or interactor, whichever of the 17 different words people want to use, and you're passing in like a kind of neutral plain old Java object or Kotlin object between these things, between the front end and back end, then you can change all of this stuff at will without having to change anything in the front end. Typically speaking, unless you're doing like a major change, which unless you're restructuring your data, which you know, if you're restructuring your data really late in the application's development cycle, that's kind of annoying. You should try to avoid doing that. All right. Well, it looks like that's about it for the questions for today. And yeah, hopefully that was helpful to everyone. If so, please let me know what people... if you have any comments about my long-winded discussion on software architecture at the start, I would love to hear them, because this is kind of a new This is a new approach I'm taking to explaining software architecture. And the reason why I am trying to move towards a more generalized explanation of software architecture is because I constantly get questions from people, explain X architecture, explain this architecture, and what I feel like the more I learn about these architectures, the more I start to see that the general principles you need to know actually sort of apply to all the different architectures. And generally speaking, whatever it's called, if it's model view, view model, model view controller, model view presenter, or whatever you call it, it's going to have something to draw the user interface, something to handle events and logic and make decisions, and it's going to have stuff that deals with data, that stores data, that exposes data. And that's basically the fundamental building blocks you need for any architecture that I've seen so far. Thank you so much for watching, and we will catch you next Monday. Peace out.